Good morning, everyone, and I should also say good afternoon to some of our colleagues who are joining from the East Coast and the Central Time Zone. I also do see attendees from Paris and ladies from Singapore, so welcome to you and good evening. Thank you all for taking the time to join this webinar. The topic for today's discussion is cloud-based video surveillance as a service. And our focus will be to understand how it's relevant for universities, colleges, and the K-12 schools. My name is Rajiv Tak. I'm the VP of Marketing at Cloudastructure, and I shall be your host for the session today. Joining me today are two veterans of the video surveillance and the security industry. Our first speaker today is Rick Bentley, CEO of Cloudastructure, and he'll be followed by Steve Kiss, who is the CEO of Gazos Creek. Before I introduce the speakers, I just wanted to cover a couple of points. Maybe we can just start off by talking about what we hope to cover today. So we'll start off identifying some of the security challenges faced by schools and universities. I think we are all aware about the increasing incidence of shootouts, increasing violence and vandalism that we are hearing about in the news. But we are also going to dive into some of the new regulations that are coming down the pipe, which is kind of creating new requirements for universities and schools to provide a safe learning environment. We'll then get into details of why cloud-based video surveillance is best suited to address these challenges, not just technologically in terms of how it kind of enables better network management, but also in terms of value adds in terms of day-to-day operations management, as well as in terms of remote access to the video feeds. We'll then share learnings from the deployment at over hundreds of customers, including ones in the education sector. And in fact, Cloudastructure and Gazos had the unique privilege of partnering together on one of the large deployments at one of the larger universities in the UC system. Finally, we'll get to some guidelines, recommendations, and best practices to consider as you think of executing your projects within your organization. This session is scheduled for about 60 minutes, with the first 45 minutes for presentations by Rick and Steve. And then we're going to open up the session for about Q&A for the next 15 minutes. At the bottom of your screens, you're able to see a chat window, and you should be able to type in your questions. We've also received some questions over the emails from folks who were not able to attend but wanted these questions to be addressed, so we will cover those as well. And in case we don't get to your questions, we will definitely get back with the response through the email. One of the most often asked questions is whether the copies of this presentation will be available, so the answer is yes. It will be on cloudastructure.com, and links of the presentation and the recordings will be made available by email to all the attendees and the registrants in the next 24 hours. So before I just wanted to do a quick introduction about who Cloudastructure is. Cloudastructure was founded in 2013 by the merger of Connext and Reed Systems. Connext was one of the industry leaders and one of the early adopters of cloud technology in the video surveillance space. And Reed Systems had done the same in the access control systems area. And it was a natural synergy that brought the two companies together. And the combined company, Cloudastructure, is focused on delivering a cloud-based, leveraging a cloud-based infrastructure for building management, automation, and security systems. Our product focus essentially kind of revolves around the video surveillance offered as a service, again, access control offered as a service, and also using our IoT gateway technology, we are able to deliver custom IoT service solutions for your requirements across different verticals where we have domain expertise, such as the K-12 schools and the higher education, utilities, telecom, high-tech, transportation, restaurants, and retail stores. So with that, I want to introduce the speakers for today. Our guest speaker today is Steve Kiss. Steve is the CEO of Gazos Creek. Steve has over 25 years of experience in information technology and design engineering. At Gazos, Steve leads the organization focused on strategic consulting and advanced technical service solutions. His expertise is in network and systems engineering, data center, network and security operations. He is the guiding light at Gazos, driving the strategic direction as it delivers industry-leading services in multiple verticals, including K-12 and higher education, hospitality, transportation, and energy. Prior to Gazos, Steve held a variety of senior IT and manufacturing roles focused on field and resident engineering. Steve received his BS Finance degree from the McLaurin College of Business. Our second speaker is Rick Bentley. Rick is the CEO of Cloudastructure and has over 15 years of Silicon Valley startup experience. He was founder and CEO of Televoke, which was later acquired by Decarta, where he raised venture capital from some of the most respected firms. He also established strategic partnerships with billion-dollar organizations. And Rick was brought in by the investors to be the interim CEO of American Staffing LLC. He was a senior consultant at Bearing Point, which included 2 assignments to Gazos. And prior to that, Rick was at General Magic, where he managed the Portico programs, derivative of which serve over 1 billion subscribers today. Rick is the author of multiple patents and patent filings and received his BA in physics and MS in engineering from UC Berkeley. So without any more delay, let me just hand it over to Rick. Rick, all yours.
Thanks, Rajiv. Well, hi, everybody. Deploying video surveillance and other security measures in the university environment has some special requirements that come with it. And I think there's a lot of things to consider when putting one of these together. The bottom line is when a parent sends their child off to a higher education institution, they're expecting that child to come back safe. And so security of the students and faculty on campus is part and parcel with the university's mission. There's a lot of new legislation coming down we'll talk about a little bit about later. But I'm going to jump right into video surveillance and the history of it and how we got to where we are today. Originally, everything was done on VCR on tape. And that means that the video is not portable. It's right there in the recorder, unless you're swapping tape out and taking them off site or something, which a lot of people put a lot of effort into doing. With the death of tape and the rise of the hard drive, people came out with the DVR, the digital video recorder. So everything's stored to hard drive, but it's still local storage. And it usually came with a monitor, mouse, and keyboard. DVR is just the evolution of DVR that has an Ethernet jack on it. And you can now access the video remotely, but the video is still kept at the NVR. And it still has a monitor, mouse, and keyboard for local viewing, typically. CVR, the cloud video recorder, is new and different. There's no monitor, no mouse, no keyboard. No sits down and logs into it. It sits in a closet somewhere, typically, or a data center. It just has enough storage on it to do caching in case of broadband outage. So, a few terabytes would be plenty of space for your typical CVR. And so there's no NAS or SAN requirements. And it uploads the data to the cloud, and then the user gets the video from the cloud via their browser or other device. So NVRs are really just one generation back. And the way it's been is that you put one NVR in every building. So you had 27 cameras in one building and 13 cameras in another and 40 cameras in another. You'd have one NVR for each one of those buildings. And that's a real headache because you don't know if these systems are up or down, if cameras attached to them are up and down. If you want to add users globally across your campus environment, you have to log into every single NVR at every building to add them. So you can imagine a scenario where you have 20 buildings, you add somebody, then you provision 7 more buildings and deprovision 3. When that person leaves, are you sure you got them out of all 24 buildings, for example? And there's a lot of problems with storing everything at the edge like this. You need relatively large storage systems in every single building. And each building may not be well adapted to supporting critical IT environments at the edge like that. So there's a few different ways that you can deploy stuff today, and they're all valid in different scenarios. But we're biased, and we think there's a scenario that's the best in most of the cases. So let's just step through them really quick. You can centralize all your NVRs in a data center on campus. And all the cameras will be streaming 24/7 all the time across the LAN fabric from every building back to your data center. That's a lot of LAN traffic, and Steve will talk about some of the architectural challenges with that later. You might get central management out of that, but for a lot of solutions, you actually still win. And you then have a very high IT footprint because you now have a large storage area network. You know, you may need to store a petabyte depending on your storage needs back at your data center. And that can be not just a huge cost, but a huge support issue going forward. We talked just in the last slide about the distributed NVR model, which has been kind of the default for the longest time, one NVR in every building. That does bring the LAN traffic down low, but there's definitely no central management. And you still have a very high IT load. And you've got storage out the edge that needs to be supported and maintained and monitored somehow. We've seen some customers centralize their CVRs into one large data center. That still has the same LAN traffic requirements of the NVR, but management is centralized for sure, and the IT footprint becomes very low. Now you're storing, you're back to terabytes in the data center, even if you have petabytes in the cloud. Because again, it's just a cache in the event of the WAN not being able to keep up with the upload requirements. And the CVR distributed model is the one that, in most cases, makes the most sense. That's where there's a CVR at every building. The LAN traffic stays very low. The central management is trivial because everything's done through the cloud. And the IT footprint is minuscule. So that's one we see gain the most attraction to stay. One thing that comes up a lot, people say, hey, we've got cameras with an SD slot in them. Can we just record there or cache there and upload to the cloud? And if you look at the overall cost of the project, fundamentally, what are you paying for? Well, if you're paying for storage on SD cards, it's a lot more expensive than paying for storage on hard drives. And if you're paying for processing power in every camera, that's a lot more expensive on the embedded micro or ASIC or whatever it is in each camera versus the x86 architecture you get from Intel or AMD at the CVR and in the cloud. So fundamentally, the best overall cost-effective approach is dumb cameras and smart recorders, whether those are CVRs or NVRs. That'll save you money in the short and long run. So when you look at the cloud solution versus the NVR solution, these CVRs can live anywhere. Some are wall mount, some are desktop, some are rack mount, whatever your needs are for each building. And you're buying storage based upon days, not upon terabytes. So you can imagine a scenario, we see a lot. Someone starts out with 100 cameras, and then next year they've got 300 cameras. Well, that means they bought the wrong storage system when they had 100 cameras, and they have to provision something new. With cloud storage, you're just paying for the number of days you want the storage done, and you have to worry about if that's terabytes or petabytes. You're not expected to scale your storage as your duration and other needs change, number of cameras or durations. The centralized management is a key part of the cloud solution. Adding people, access to videos, what happens in emergency, that kind of stuff is all very well-defined and easy to manage versus, oh, that's a third-generation old recorder at that building, and here's the credentials on this piece of paper here, and I'll get those to the person who needs to get a hold of video now somehow, maybe. When everything's centralized, things are just much easier to manage. And in terms of maintaining the system, if a camera goes down, an alert goes out. If a CVR goes offline, an alert goes out. Everything's monitored centrally. And this is done with no VPNs or other sort of crazy things you need to do to keep everything on a common network fabric. You can have remote buildings off campus on Comcast or Verizon or any other type of network, and they all fold into the cloud with no stitching together of networks or anything else. The Chancellor's house, for example, on he could have DSL, and he'd be part of the same solution. So for the bit heads in the audience, just talking about the life of a video recording, the way the way we do it is we think important, and that is everyone will tell you about how great their video compression is. And there's a lot of great video compression out there, and we use what we think is best of breed. But you have to be a little bit wary about what people are selling you. Anytime you compress video, or almost any time, that is what's called lossy encoding. You're throwing away bits that you can never get back. And a lot of these encoding algorithms are made for Hollywood and for DVD playback. You know, they're a big consumer of this stuff, and they drive a lot of the work in the space. And so you can imagine that what you want to have for DVD playback is very smooth frame rate, for example. But you might pause an action scene, and you'll see a very blurry thing moving across the screen, and that was done intentionally by the encoding algorithm to make for a smooth-looking playback. That's a problem if you're trying to freeze a frame and see what someone's face looks like when they're moving across the field of view of the camera. So it's important to go for the least lossy encoding possible. And so we take motion JPEG from every excuse me, motion JPEG from every camera to the CVR, and there we encode in MPEG-4. MPEG-4 Part 10, also known as H.264, is optional. We don't think it's the best one. It's more lossy than straight MPEG-4, but we can do it. And then we upload from the CVR to the cloud. Everything's stored in the cloud, and you play back through standard browser. So why is the cloud model for education? You know, the camera provides it on a common LAN, except when it's not. So outbuildings, as we mentioned before, other places that are far away on a different network fabric can all be served with one continuous model. There's the ability to add and subtract cameras very easily. All you need to know is the camera's IP address effectively and the credentials for it. You can add it to the system. Likewise, you can add users equally trivially. And then we can do integration to other things like access control systems. So camera can unlock a door. So you can have remote receptionists, basically, who can see who's at the door and buzz somebody in. We can also do integration further downstream with alarm systems, so batching in disarming alarm and a double batch armsing alarm, for example. If you look at the total cost of ownership, if you think about the cloud model, you're not buying machines that you then need to put an operating system on and maintain and install patches and updates. And when, excuse me, when the storage is in the cloud, you have a much lower footprint in the data center, which means smaller storage networks, fewer machines, which means less power, less rack space, less cooling, less backup power, all the stuff that goes with the cloud model. And when it comes to delivering it, you know, the prices are below $1 per day per camera. So when you start to add in all the different costs of a competitive solution, with the NVRs, with the operating system and the third-party software licensing and the maintenance of it all, I think you guys will find that it comes back considerably less expensive and certainly a lot less headache, greater reliability and other things when you push into the cloud. Basically, your old problems become our new problems, but we're very good at addressing them. We have a business around to doing that, and Visual Events is typically ancillary to other people's businesses, so no point with them becoming the expert. So with that, I'm going to hand things over to Steve Kiss, who has seen a lot of these installations, and he'll give you a lot of the gotchas in advance.
Great. Thanks, Rick. So, by way of background, I'm just going to roll through my slide here.
I can say that now.
Okay. So by way of background, just to kind of establish a little background on myself. I started out building large-scale multi-services networks for an organization. As part of that role, we needed to start carrying video transport, and that was really driven out of the security business and out of IP camera-based systems. So even before that, a little bit around voice over IP. It's been a challenge. It's been a challenging part of the deployment is to figure out how to efficiently carry security camera traffic efficiently and reliably in the network without with maintaining the integrity of the video, but also without damaging the existing traffic, the traditional traffic on the network, the business traffic. And so we've done a fairly good job at that. In the last couple of years, we started to see this growth in this CVR business, where some of the problems that we have had to work very hard around are starting to diminish. We can start dealing with some of these problems in other ways. And that's why I'm excited to talk about this component a little bit today. I'll talk about how to set up the environment, some of the gotchas in that environment, and some of the advantages to that CVR environment.
Oh, here, let me move this out of the way. Look on the screen here, you can see the next.
Okay, great. All right. So, I think it's real important to start out by talking about what you're trying to protect in a campus environment. We do tons of campus deployments across the U.S., including higher ed. Most of the time when you're in campus environments, you actually are doing different types of services and support services for different types of activities. And the cameras should each be identified as to what their purpose is. I'll note later that some of the cameras are better served by live view or by other types of storage, but in general, what's important to kind of get across is the types of services that the security pieces provide. I'll hit this in a couple different ways in the slides going forward. First of all, the one that's most obvious is crime detection, just identifying crimes that are being committed on the campus. The next piece is insurance and false claim components. This is important in the area of like art museums and areas where you're providing services for maybe art that's on loan. Employee safety, another component. Casualty response, loss prevention, product reliability. This is not so important in the campus in higher ed. And then regulatory requirements. We're starting to see that regulatory requirement coming in. And then integration with doors, as Rick talked about. And finally, the one that's most interesting to me is vandalism deterrence. It's the one that campuses lose so much money on in just vandalism and just raw paint and facilities work to try to cover up the damage that's done on campus. So all of these have different ways that you implement the camera deployment, and I'm going to go into those pieces. So let's talk about this hosted versus in-house deployment. In the hosted environment, this is great for after-the-fact deterrent. It's great for construction cameras, safety, multiple sites, and departmental budgeting. There are some places where the in-house building the in-house DVRs still has a place, and that's in the area if you have a lot of security, SOCs, live viewing walls, that sort of area, or if you have the area of analytics. If you're doing leave-behind packaging for analytics to determine if you have bomb or terrorist issues that you're trying to work around, and if you have intellectual property implications, there may be some reason to store that stuff locally. But for the overwhelming majority of deployments that I see in the campus environment, this idea of moving to the hosted environment, such as this Cloudastructure piece, makes some sense. Also, it's important to note that there's a hybrid model, which I see being deployed and I've been part of, where since the cameras support dual streaming, you may do live viewing directly to the camera and be doing streaming to the cloud. The advantage to that, as Rick indicated, is getting all that storage infrastructure out of the environment. So what's the process for kind of building out one of these environments? If you like the idea of the cloud-based environment, the first piece is to develop a strategy for security coverage. That starts with the previous slide, which talks about what's the purpose. I'll hit that a couple of different ways throughout this presentation. The other piece is to start coordinating with the stakeholders. This is a really different model, right? So normally you'd have to have a campus-wide initiative in order to deploy camera systems inside campuses, and most campuses already have some sort of NVR structure. How does that get broken up with the facilities component, with the IT component, and campus police? Those are kind of the key players in the environment. But instead of worrying about infrastructure as being the primary driver, you now can look at what the business needs are and how they're met by the different folks. The next piece, obviously, is design and engineering, something that my organization does, and then the coordination of the installation, cabling and storage, and then performing the camera aiming and documentation. The camera aiming then becomes one of the critical components, and I'll go into some of those as we go forward. In order to drive this idea of what is the purpose of the camera at home, I took a still of one of our deployments at the school, and I want people to kind of get an idea of what our goal was for each camera. And cameras can have more than one goal, but they really have a primary purpose. So in the first one that I want people to focus on, you see the alcove here, you see that leading to that doorway, we have some low-light personnel protection. So because of the way that these cameras are mounted, in servicing this area, we're able to actually pick up kind of this low-light area that doesn't have any natural ambient lighting. I'll make note also that that the cameras can provide illuminators as part of the PoE component, and that will allow us to actually provide lighting as part of our overall security. So the next one down is parent pickup. So in that type of deployment, you're really looking for high-fidelity cameras to get some facial identification. This is different than facial recognition. But just in case there's a problem, we can go back in the film and look to see who picked the child up. So even on the campuses that I'm involved with that are higher ed campuses, there are these playgrounds and daycare that's part of this student, faculty, and staff environment. And so these areas require special cameras, special fidelity on those cameras to make sure that they're aimed in such a way that we know who's being picked up by what child. Just a statistic, 85% of all child abductions are by family members. So it's something that the preschool operators on our campuses deal with. The next area is kind of my hot button graffiti. Just easy to identify ways to deal with graffiti. We want to turn that into a direct action so that when we see those frames come up, we're responding, right? Very, very hard to do after the fact prosecution on graffiti. The police departments are overwhelmed. They're usually not prosecuting. So you want to go after these people right away. You want to make that stuff available. You do that via live feed. Telecom terrorism. In the Bay Area where I operate a large portion of our business, there's been several actions of telecom terrorism. This is not some esoteric item. Single points of failure in the fiber network. Basically, go into one of these fiber boxes. Here's a picture of one now. You damage the fiber box, and that fiber is down for a day. So it's becoming a big issue. We want to watch these boxes, not only for our own campus ingress and egress, but also for partner institutions that may be near campus. So research facilities that are being serviced from the main campus demarcation point. And then the last part is that insurance claim that I mentioned. If you have uneven services, you already know some of those hot buttons through your insurance facilities. Reach out to those folks that are responsible for that in the business units, and make sure that those areas of high risk are being monitored so that you don't have false claims. Bear with us a second.
There we go.
Okay. Let's talk about some implementation lessons from our work. A little bit now about physical layer. I think that this is where a lot of folks get tripped up in their deployments. We talked about what's the goal for each camera, but we need to talk about when and where you're interested in the views. For each camera, you should be taking a schematic drawing of the area and starting to draw the view that you'll get for that, and then trying to determine if there's anything that's going to block that view. Vehicles, sunlight, trees, those sorts of things. So getting the view component right first is really the driver. So you understand what you're looking at and how you're going to get to that view. As you do that, I'll make mention that a lot of the driver of the install, at least on the wired camera side, is determining what the best access is for the physical plant, for the wiring. So the high-resolution cameras that are available today, you may have different options for mounting that give you the same view. So you could come from both a north position on a building at 300 feet and a south position at 100 feet and still get the same resolution. So you want to be looking at what those capabilities are for the physical plant and what the easy mounting pieces are. That's usually driven either by IT, but often by facilities, because you're talking about interoperation with other building mechanicals to try to get to certain places. So we're talking about what's the most economical mounting for that. And then also what's most tamper-resistant, right? So whether or not you buy the tamper-resistant installation kits for the cameras, make sure that you use mounting hardware that is tamper-resistant. Make sure you use Allen head screws. It's a little harder than people just carrying a screwdriver. Make sure you make some of the hardware decisions that you can that help make your cameras both physically difficult to get to and physically difficult to dismount or change mounting. Then the next piece is power. Most of the cameras, for cost reasons, that you'll be looking at are power over Ethernet. Power over Ethernet comes in a couple different variations. The original standard called AF is basically a lower power piece, 4 or 7 watt power. And as you move to the higher layer, higher power for your pan tilt zoom cameras, your PTZ cameras, you want to consider being able to support power over Ethernet at 29 watts. So that's the maximum allowed on the power over Ethernet plus component. I'll make mention that I've written a little white paper on this, but creating a power budget for your cameras is critical. So that's what you're doing around that is you're basically determining how much power your Ethernet switch is going to allow, and then making sure that your switch supports that amount of power for your cameras. So power for cameras, power for PTZ cameras, plus illuminators will give your total draw, and you just need to make sure that your switches support that. Most power over Ethernet switches will not support full rate power distribution across all ports. 48 port switch will not support 48 ports of PoE+. Okay, so now the next piece is the cabling. It's really easy when you're building small deployments and you're starting out and you're not worrying about scaling to just throw some cable in the ceilings, to drill some holes in the walls, to get some exterior cameras up. But because of scalability savings on the Cloudastructure products, I think it's important to start thinking about really taking scalability seriously and from the outset developing standards around cable plant deployment. I see a lot of campuses that have cable standards for UTP for their IT infrastructure, and I've encouraged numerous campuses to rethink their cable standards to now separate IP cameras as separate from other IT cabling infrastructure. And the reason for that is pretty simple. If I'm doing cabling infrastructure for a PC, that PC for one generation over the next may have dramatic changes in its demands, but the cameras for the most part do not. So when you are using camera deployments and being cost effective in your deployment, you just want to use the right standard of cable that provides just beyond what the requirement is for cable plant. And you don't need to be looking at cable that supports 10 gig over copper or even to some extent 1 gig over copper. You need to kind of right size that for the demand. So we're talking about category 5E or better, and we're talking about nothing below category 3 for the cable plant. And these are all EITIA standards.
Yeah, I think it's easier.
got it.
Okay, thank you. So, proper performance is kind of the key. The next piece is just to discuss transition and cable plant type. Obviously, if we're going to be using cable that's outdoors, it's important to use outdoor rated cable. If we're using cable that goes in a riser, we need to make sure that we are cognizant of fire code for smoke. And if we're using direct bury cable, we've got to have ones that are rodent resistant coating on the direct bury. So transitioning and using the right cable is something that the IT organization can usually assist with. Usually facilities can get involved and so forth. But using the right cable and not just stringing stuff is kind of the underlying point. Just a little bit on performance. I'll leave the slides for the distribution for those of you that want it. But just talking about the camera, thinking about in this structure, camera to the edge performance, edge to core performance, and core to WAN performance. So what the Cloudastructure system does is it starts to separate the performance requirement. It's a really key point. So at the edge, where you're in a switch network, you need to have the highest level performance, and that's great because you usually don't have any contention in that. You're probably not sharing the connection from the edge camera to the ingress switch. And so we're looking at the highest performance there at 1.5 meg to 10 meg performance up to 1080p. So that's a reasonable capability in most Ethernet switches. Coming out of that switch, you'll have to do a little math and make sure that your upstream switch performance can support your network. And this is where Rick talked earlier about starting to think about whether the CVRs are on the edge or whether the CVRs are centralized. If you have good bandwidth and good bandwidth protection, you may want to take advantage of your network and centralize those CVRs to further help in management. But if you don't, you can put those CVRs at the edge. There's not a lot of maintenance. There's not a lot of power requirement. There's not a lot of cooling requirement, so you can get those things out to the edge. The real rub here comes in just understanding whether or not you have VLAN performance metrics that you can accomplish with the cameras that are coming in. These will be really related around protocol prioritization for video streaming and guaranteed delivery and bandwidth. They're fairly easy to set up around the different VLAN components. The area where you need to be a little bit careful is the on and off campus pieces where you have different network bandwidth that you're trying to carry VLANs. You're trying to span VLANs. And in that case, you may want to just split that and come up with different VLANs for different regions. So kind of breaking the VLAN virtual model into a physical model. And that should help kind of resolve this. If you centralize your pieces, as I said, you get that centralized help of being able to centralize the environment. If you put it at the edge, then you get the reduction in bandwidth. So this is kind of an explanation of that, the last component, which is just CVRs at the edge versus CVRs at the core. Limited bandwidth. You can make some decisions there as to how much bandwidth you allocate and what sort of networking you need to basically make that pull forward. So one last thing to consider is the maintenance on this. For so many years, we've seen folks install cameras and security systems, and when they finally need them, when the day comes, they have not done a maintenance component on it. Because of the kind of model, the pricing model that's built around monthly or yearly costing, from a budget standpoint into a department, you can also bundle the maintenance component. We've done this at several clients. Instead of having this large upfront asset purchase, that then the maintenance component is lost in that therefore results in kind of failure when the cameras are needed. Since you're doing a month-to-month or yearly cost on the back-end infrastructure anyway, roll in the maintenance component on this and build that into departmental budget. It's a really smart thing to do. Nothing's difficult. I'll speak to a little bit of experience on this. Nothing's more difficult than looking at a building arson on a campus and seeing that through a spider. It's very difficult. It's very discouraging, and there's really no reason for it. Re-aim the cameras, Make sure that nothing has grown into the middle of the space you're trying to look at. Verify the cable plant to make sure there's no damage to the cable plant. Look at the switch port configuration to look at the output for the port allocation, and then clean lenses and check the connectors. Kind of really will get you out of a lot of trouble. So that's kind of my view of the implementation gotchas, how you can be successful in the deployments. Thank you for your time.
Thank you, Stick. Thank you, Steve, and thank you, Rick. This was a very informative presentation. We're going to open up. I do see questions already coming down the pipe, but feel free to kind of use the chat window to post any questions that you want to have Steve or Rick answer. So let me get started with a couple of questions that I see already on the our moderation board. And the first one, I think, Steve, this one would probably go to you. And it says, it reads as, how would a cloud-based system uptime be maintained through an IP provider with aggressive firewall protection so that the current incidents and situations could be addressed timely over the internal network when the cloud is not accessible? This came from Terry Thetford.
Okay, so that's, I want to break that into two questions. First of all, let's talk about the network component. In a campus-based network, you really should be looking at how you can make your network more resilient for all of your users, not just the video users. So, so that really comes down to building resiliency into the network. It's a critical component. If the Cloudastructure network has degraded performance, it'll do some management of the available bandwidth. That's a great feature. But it's incumbent upon us that our network builders to also build those resilient networks. So what do you need? It's pretty simple. You need to have multiple paths so you don't get caught by a backhoe and your line gets sliced up. So you need to, on a campus, have multiple input points to the network. You need to have network electronics that supports that in a redundant fashion. And you need to have the infrastructure in the form of power and cooling that supports those pieces. So the first part is just as good network protocol outside of network security, you need to be thinking about that. The second part is the firewall component. The Cloudastructure stuff supports HTTPS, which should be being passed across most networks anyway without any firewall modification. So that's a good thing. The second part is, since you're doing this store and forward mechanism, you're not taxing the firewall. Right? It's something that when we build the networks and you compare hosted versus cloud-based, hosted versus in-house, you don't really think about the extra burdens you're putting on your firewall by taking everything and streaming it across your network. So in this case, your firewall component probably doesn't need to change. The protocol, one of the standard protocols that you use, and the streaming timing is not that critical.
And one thing I'll add to that is this kind of assumes that all of your responsibilities are served by one ISP or one broadband connection. Again, with multiple outbuildings, et cetera, it's a nice in the cloud model that any building that's got connectivity is uploading, and anyone can get online can get to that video, regardless of what's going on in one spot or another.
I see, thank you, Steve and Rick. I see another question coming down. This question is from Danielle, and it reads, how do you implement using existing camera systems? Can you use existing cameras? And I see another question which is basically addressing the same topic, and the person's asking if we could utilize old analog cameras, or would they need to kind of, buy new IP cameras to be used with the cloud storage service?
Yeah, so camera takeover, excuse me, camera takeover is very common. The cameras tend to last longer than computers, for example. There's a lot of old analog cameras out there that still work, and it costs a lot to replace them. For analog cameras, you just need to get what's called a video encoder or a video server. It's got one or more coax inputs on one side and an Ethernet jack on the other, and that'll take the analog cameras and turn them into a virtual network camera. And there's even rack mount ones from Axis where you can, it's a blade type system, 4 analog cameras per blade, I think 10 blades per chassis. So you can put 40 analog cameras into 4U of rack space, or the conversion of 40 analog cameras into 4U of rack space. You can really do high density takeovers of analog cameras. For network cameras, yes, with some caveats. The Cloudastructure system can support almost, excuse me, almost any kind of network camera. We're only looking for a motion JPEG stream from each camera. We kind of ignore the loss year encoding that they're trying to do in that small micro that's on board. So that's a very common feature set that we can usually get a hold of. Now, for some lower-end network cameras, they only support one stream, which means if you're recording at 640 by 480 and someone views the camera on their phone at 320 by 240, you've just changed the recording to a lower resolution than what you're hoping to get. So we encourage people to get cameras that can support at least 2 streams, if not more, just for this usage model, if nothing else. But yeah, generally speaking, we can take over pretty much any digital camera and any analog camera.
So I'll just add to that. So we've done implementations, and there's a little bit of technology hat that I wear, but also in this business hat, I'm sure some people caught some of my comments earlier about how budgets go, how to budget for this. So we've got a site that's got a little over 7,000 cameras, and they're all analog cameras, right? And to move that from an infrastructure standpoint, even if you had the budget to do that, is just a monumental physical task. So the customer came up with a game plan to basically quarter by quarter start to move off of their analog cameras onto IP cameras. But that required a whole infrastructure upgrade along the way. So they're tracking at about 500 cameras per quarter that they're moving. So that's a pretty big process for them to move from that 7,000 at 500 at a cut. It's still a big undertaking. They get some advantages, as Rick said, as they move through the the cutover, but they still maintain those cameras, and they pick those cameras based on ease of cut and also based on ones which were most critical, where they needed multiple streams with PTC capability and what have you. So that kind of blending does work out well, and the back-end infrastructure could be incrementally applied to the environment.
There's one more question. In fact, there was a bunch of questions around the same topic, around having an NVR and trying to kind of move over to the cloud storage. But let me specifically address the question coming from Sridhar, who's on the call today, and he's asking, do you provide SaaS offering, or do we need to get our own cloud storage? So this one I can answer that we do provide the SaaS offering, and we also provide the cloud storage as well. But the other question that he has is that he has an NVR, and can he connect to a CVR to take advantage of the cloud storage? So you may want to address that.
Yeah, we have done some deployments where an NVR stays on site in parallel with a CVR. Sometimes it's just handy that the NVR has already been bought and paid for. Sometimes there's no reason to turn it off. I think it's an analog deployment where you just put T connectors on the coax cable, and you've got a parallel system going that pushes to the cloud. I've seen it in digital deployments where you've got a network camera that can support more than one stream. One goes to NVR, one goes to CVR. So you have on-site storage and off-site storage, kind of like wearing suspenders and a belt. It's a little bit of overkill, but if you have an extreme need for reliability, you could look at the cloud solution as an off-site backup solution in that regard. And it makes for a fully redundant system.
And another related question to that question that Sridhar had raised, and it reads as, we have an existing NVR in one of the buildings supporting 15 to 16 cameras. How can we enable remote access to the feed? Does Cloudastructure support that transition?
Yeah, absolutely. So the easiest thing to do would be to put a CVR at that building, have it record from those cameras, and push them to the cloud. Then wherever you are, as long as you have broadband connection and a browser, you can get to that video. And that'll be with no port forwarding the router or holes in the firewall or anything else you would normally need to do on site.
So let's just think about that just a little bit from a campus perspective. I just want to dive down into something, because I think that one of the areas that I touched on was personal security of faculty and staff. There's no reason why the campus police should not be carrying smartphones or tablets and be able to reach the cloud via off-network connectivity. So in other words, 3G or 4G access, and be able to look at video feeds of the environment. And this, you're touching on some topics on transitioning networks from existing and paralleling, but the ability to do multiple streams in the camera really gives us some tremendous advantages. Live feed for incident response, as well as having storage that you can take advantage of later. It just makes sense to be able to offer that capability to campuses. And if you think about what the cost of doing that system across multiple buildings, there's no good way to get into that from an asset perspective other than to start with a very large pot of money. You can't ease into it. And just to kind of answer that question, I see these as ways to start to dip your toe in the water in this and try one camera at a time to get there. It's just a much simpler way to do it.
Another related question about the storage. Is there a limit to how many terabytes of data can be archived? Can I retain video surveillance footage for a year?
Yeah, so that's really one of the key advantages of the cloud-based approach. You don't have to figure out all your storage needs now. Whether it's a number of cameras, which can vary from 10 to 1,000, depending on what you're doing, or a number of days of storage, which would go from a month to years, depending on what your data retention policies are. Either one of those can change the equation by an order of magnitude or two. So with the cloud-based system, you just tell us how many days of storage you want. And whether you've got a huge megapixel camera that's got constant motion, or you've got a little 640 by 40 camera that's pointing at a fire exit that never sees any traffic, the cloud systems charge you the same for that. So rather than thinking about terabytes or petabytes, you just think about number of cameras and number of days, and we take care of the rest. Our standard retention policy is 30 days, but for $5 per month per camera, you can for $5 per month per camera, you get an extra 30 days of storage. So you can get a year of storage for an extra $60 a month, for example.
The next question, I think it probably addressed at Steve. Steve, can you use more than one PoE port for a camera setup?
Oh, okay. So basically, in the PoE world, there's reasons you may do this. So one of the big driver costs of deployment is the back end. So the Cloudastructure guys seem to have really knocked that down. The next piece is the infrastructure piece, and we've traditionally built either very complex coax systems or systems that have a hybrid of power and video transport. Now that's pre-PoE, but when you run into the PoE system, you start to run out of, you have all these extra capabilities. So your PoE system can actually drive lights. I referenced that one camera location that was a school with a darkened doorway. So if you're trying to catch someone, you may want to use infrared lighting that's not visible to the eye. But you can use PoE systems, PoE lighting from different manufacturers that is actually in the visible light range. So where you have dark spots, just as an overall security measure, you can add lighting that's powered by the Ethernet switch, which is great, especially with these LED lighting. It's very, very efficient way to do it. So the simple answer is not on the same camera, but definitely in the same system as you're designing it.
There is a follow-up from Sridhar that I see on the, and this was to one of the early questions. He's saying that he already has an S3 and an Azure storage. Can I point CVR to store it to S3 or Azure?
So we have everything on our own back end, in our own data centers, and we have a highly efficient storage mechanism. We borrowed an open source hardware design from a company called Backblaze, and open source solutions including Gluster and others. And when we do the math, we find that our cost of storage is much, much lower than it is for anything that Amazon offers. Because you have to pay, you can't use Glacier storage, for example. You need the storage to be online and available. And you have to pay to get the data in and out on the broadband charges, et cetera, with Amazon. Now, if someone want to talk about a custom solution where they had some real business need to use Amazon as a storage environment, we sometimes do for very large deployments what's called a knock-in-a-box, which is essentially a copy and paste of our back end into someone else's data center. And that copy and paste could be to Amazon just as easily. But you need to have many hundreds of cameras or more before that pricing model starts to make sense again.
Steve, this one then is probably for you. At what stage of the camera surveillance project should the installers get involved? What do you think of, it's probably two questions. What do you think of wireless cameras from a reliability standpoint?
So from a stage perspective, I think you can divide the installation of the cable plant into two pieces, the infrastructure and then the actual cable pulling. So, so you need to have those cable plant guys in early enough that they can provide guidance for costing. So if you really want to have an efficient system and one that's well built, frankly, you want to be thinking about how you're going to travel the cable from the nearest TC or IDS out to where the camera is located. So, so the pathway component comes in early. As far as the cabling component, I think that can wait because you should already have a cabling standard, as I talked about, that's specific to your cabling needs. So that shouldn't really vary. And even on budget, you really configure budget out. I have a formula that I use, and it really holds up. So I don't even need to get cabling folks involved to the very end. On the wireless side, you know, it depends. The wireless space. So let's define that just a little bit. So there's two types of wireless. There's regulated and non-regulated. I'm assuming what we're talking about is the regulated piece. And in the regulated piece, this is specific to FCC regulation, by the way. This is not specific to type business. But in the regulated space, you own a set of frequencies. So some campuses, especially research campuses, may own a certain frequency that they get control over. In that case, if you're using that frequency, you have control of it, right? Someone has control of that. And I see that heavily in airport design. The airport will own certain frequencies, right, that may sit up against Doppler radar, or they may sit up against certain spaces, and they run that on those frequencies. That's a fairly stable environment. When you start to get into the unregulated band, this is where you go down to your nearest store and buy a wireless camera, and it runs on Wi-Fi. You need to be much more careful. You need to do a frequency analysis to make sure that that environment's in place. You may not want it. You may want to have air monitoring available so you know when those frequencies are being attacked by others, because there's nothing that regulates someone from coming into that space. When someone comes into that space and starts transmitting their web surfing, your camera may be impacted. So oftentimes you're using this. Let me give some examples. You're using this because if you go across a roadway, you have to tear the roadway up. If you go across a lot, it's an archaeological site. I have that in a facility that's an outdoor botanical garden. It just makes sense to use wireless. But nothing comes for free. You need to be very, very careful how you're doing it. And with the cost of cameras, it may make sense to have more than one camera covering in the wireless environment, coming back into your environment to cover the same area, just because of the higher risk level of going wireless.
So I noticed that we're just about a minute away from the time that was allocated to us, and I do have a fairly long list of questions still coming through. But what we're going to do is we'll just wrap up here. Maybe we'll take one more question, which is the last question that came from Sridhar, asking that we are in a regulated industry. We need vendors to be HIPAA compliant. Is your solution HIPAA compliant?
So we do a lot of HIPAA design work in hospitals across the country. It's actually the place that I started our company. I'm really familiar with that. The installation itself needs to have a VA agreement. That's not an issue. And so the installation that we do is, I'd have to check to see whether Cloudastructure is, but from Gazos' perspective, that's a reasonable expectation and one that you should
okay, so we'll wrap with the last question. Our cameras come with SD storage. Can I stream straight to your cloud? Why do I need CVR boxes? Rick, maybe you can answer that.
Yeah, so if you have a whole bunch of cameras on your network, excuse me, with SD storage that are all trying to upload at the same time, your IT department's not going to like you very much, very fast. The nice thing about the CVR model is we centralize the upload requests into one channel for all the cameras, which makes it much easier for the IT department to manage us and their broadband. As I mentioned before, the overall storage cost for on-site caching, the CVR is effectively free compared to putting an SD card in every camera on site. I think you find that using the CVR gives you a lot of advantages with your IT department and would end up costing less overall.
So I guess that's probably all the questions that we can accommodate in the session for today. I do want to remind you all, and I know there were quite a few questions about that copies of this presentations and the webinar recordings will be available on our website, www.cloudastructure.com. And all the registrants as well as the attendees today should be able to get this in their inbox as well. This should happen within the next 24 hours. And before I leave you, I wanted to also remind you that if you are in the process of designing or upgrading your video surveillance systems, Cloudastructure is offering a free 2-hour workshop or a consultation session with the teams from your organization. And if you would like to take advantage of that offer, please send an email to info@cloudastructure.com. So with that, let's wrap up, and thank you so much for your time, and we hope to see you again in one of our future webinars.
Thanks, everybody.
Yeah, thank you.